recording here. I always forget to do that. Floor framing members. Again, while I'm talking about the terminology here, the picture is on figure 12.5 on page 208. So again, double header would be used any place that we have an opening that's interrupting the floor framing pattern, right? We would have an opening for something like a stair going up and down. Would be the most common opening we would have. We would probably have an opening there for if we have a masonry chimney going up through the floor or the roof, that would be an opening that would have a double header. You see double trimmer again on that figure. So we're just adding a little bit of extra oomph, a little extra material to carry the loads across that opening. And tail joist you see as well. And ledger. Hopefully I have that. Let me see if hopefully I'm coming to the picture here in a minute. Ledger is something that helps hold up that tail joists. And bridging is small members that basically provide lateral support between the joists. And I think I should have pictures of all these things, hopefully. Our floor framing dimensions will be shown on a framing plan. We're typically going to show the direction of the span, the member size, and the spacing, such as 2x12 joists, 16 on center. So let's see what that looks like. We talked about this in Unit 7 as well, about engineered wood products. In this case, this slide is touting them as a green material. I think they are green in the sense that we are providing the same strength with less material, right? Same strength, less wood, same performance, less wood. The downside, as I think Patrick pointed out to us weeks ago, is we need to pay attention to the fire resistance of some of these products. Again, here's our pictures of some of the engineered wood products. An LVL, or laminated veneer lumber, a composite I-beam, right? Essentially a wooden analog to what's done in steel with a steel I-beam, a W or an S shape, right? With a flange and a web. C is glue lam, right? We're basically laminating. You kind of see the division marks here. We're laminating smaller pieces of material together into a larger structural member. And D is parallel strand lumber. Again, in this case, we're taking material and fusing it or gluing it together to produce a larger, stronger member. So again, we can frame with standard dimensional lumber, or we can frame with engineered wood products. Right, here's our LVL, laminated veneer lumber. Right, you can see you can envision the different layers laminated together if you look at the beam or the member from the underside. Right, so it's a high strength wood product made from veneers, thin slices bonded together. Here's our composite I-beam. Right, we have a web and a flange, just like we do on steel I-beams. Right, it looks like someone is framing. Looks like framing something up here with composite I-beams. I think when I followed up on Patrick's question about fire safety, I dug out this information from this hull joist. Looks like Boise Cascades trade name for their joist product, engineered product. In this case, we needed to make sure we added some gyp board to protect that I-beam from fire. So obviously, if you have the I-beam as a framing member on the first floor ceiling or second floor, it would be protected naturally with drywall, although you might not use 5/8 drywall. But if you were using these wooden I-beams in your first floor or your basement ceiling, you wouldn't necessarily cover the basement ceiling with drywall, but in this case you would want to make sure that you provide fire safety in the use of that material. Right here are glue lam. And you see this is starting to look a little more like concrete or steel construction because you have larger members. And this may actually be commercial, using wood in commercial construction. Yes, Christoph.
So the image you're showing right here for the glue lam, it actually looks pretty heavy duty, I guess, for what I would expect. So is there a certain situation where people lean away from the glue lam and stick to the LVLs or other types?
Judging by this, well, like anything, you can, different materials can be used in different contexts. In this case, just judging by what I see in the image, I'm guessing this is some kind of commercial construction rather than residential. So they may be striving for a certain appearance commercially, right, by having, this glue lam as part of like an open ceiling, as opposed to trying to cover up, steel or concrete. But again, I think a variety of products can be used in a variety of applications. You just need to know the characteristics of each different product, what it's, what weight it can carry over what span. Right? I mean, this could conceivably be a wooden I-beam bearing on glue lam. I think in this case it probably looks a little nicer because you have a consistent look. But I'm going to guess you could find a wooden composite I-beam with the same structural characteristics as the same glue lam. I'd have to look up and see, which one performs better than the other for a specific size. I don't know if that addresses your question.
Yeah, thank you.
Again, I mean, think of this as a kit of parts, right? I mean, we can take the kit of parts and, especially if you're the architect, you can assemble that kit of parts or design using a kit of parts in lots and lots of different ways. As the architect, your client comes to you and says, I want, this is the program and I want this particular kind of look and feel. And for my, whatever this might be, for my clothing store or, I don't know, whatever this structure is, right? And then it's your job as the architect to deliver on your client's wishes within the budget that he or she gives you. And then again, if you're on the other side of, if you're building it, right? You're going to look at these, you're going to look at the plans and say, okay, here's what the architect is calling for. I got to go out and build it. Yes, Nicole.
Um, is the glue lamb or the LVL, are they made out of a certain type of wood? Is it like pine or does it vary?
I am going to guess it's a softwood, so pine or Douglas fir or something like that. Um, but I actually don't know I will have to find out the answer to that question. I'll have to find out what kind of wood is used. Again, I think um, in the composite I-beam, it's got the um, right. The web is made out of OSB, which is generally speaking kind of a quote unquote a waste product, right? At the lumber mill, they take those leftovers of strands and glue them together to make OSB. So the web is OSB. The flange, I think, is a more conventional piece of dimensional lumber. In the case of the glue lamb, I believe they're taking, again, you can kind of see it in the picture here, they're taking smaller pieces of dimensional lumber and gluing them together to achieve the characteristics that you're looking for, probably because it's getting more challenging these days to find a single tree that's big enough and straight enough and good enough to give you a member that large. Yes, Ayana.
You know what? I had 108 with Frances last semester, and she had a really good video showing the process that they use to make the OSB and how that all comes together. But I also just want to comment on, like you said, about how, like, much of the timber is not from old growth forest, so it lacks size. And I remember maybe watching a video and someone was saying, like, the way houses were originally built was based on, the structure and the technology of the older, more sturdier lumber pieces, and that even now, because they use younger trees that like engineer or structurally, it, some things just might not like exactly equate to now building standards versus what they were, like, because the product is very different structurally speaking.
Yes, no, you are correct, Ayana. Yes, so there's not old growth lumber is not the same, or probably turn it the other way around. The lumber that we see today, which is basically harvest, it's a harvested product, no different than growing corn or soybeans, right? You have a tree farm where you farm pine trees or Douglas fir trees, and you want them to grow reasonably fast. That's an entirely different material than the old growth forests that were cut down in Wisconsin and Michigan to build Chicago in the late 19th and early 20th century. So yeah, they don't make trees like they used to, or um, we are trying to speed up the process of growing trees, and we don't get the same results as we did with old growth forests. Yeah, I mean, I have a house with 100-year-old house with old growth wood in it, and even though it's nominally a softwood, it's darn hard to drive a nail sometimes into the members in my house, right? As opposed to if you pick up a 2x4 these days from Menards, it's you got to look really hard to find one that's not slightly warped or has lots of knot holes in it, and B, it's certainly a lot softer than old growth pine. So good points. Yeah, and I think that's part of the reason for engineered lumber products is again it's allows us to work with smaller trees and trees with different characteristics than what we had previously. Good points you're all making. Thank you. Right, again, here's another engineered lumber product, parallel strand lumber. Right, similar to OSB. Right, we're taking flaked strands of wood and oriented them in a certain direction and gluing them together and making a product out of that. I'm always a little concerned when I see things like phenol formaldehyde adhesive that what's that gonna mean in terms of outgassing or what happens in a fire. So I'm sure there are fire concerns and characteristics that need to be attended to with these engineered wood products. Okay, so back to figure 12-2. Right, so this is where the terminology we looked at a couple slides ago gets connected to a picture. So this would be platform framing. And again, we have the sill plate laying on the foundation wall and bolted down to the anchor bolt that the concrete contractor put in the foundation wall. And again, you see the header and the joists and the subfloor and the first floor framing starting to rise off of the platform. Here is our floor framing, how we handle an opening in that floor framing. Again, that opening, probably a stair opening or something else. We might have an opening for mechanical systems for ductwork to go up and down. But again, where that opening interrupts the regular pattern of the framing, we have this double header and double trimmer and tail joist resting on the ledger. Here's our short pieces of bridging, right, running perpendicular to our regular joist dimension. And this is providing lateral stability to those joists to keep them from moving from side to side or buckling under load. So this is figure 12.5 on page 208 if you happen to be following along in the textbook. So here's what floor framing might look like in plan on the set of drawings. So in this case, we have, let's assume it's a first floor. It probably is first floor framing. Down below, we have this, it's not steel. It looks like 4 2x12 beams, right? So we have a larger wooden member set on steel columns. And then the 2x12 floor joists are running perpendicular to that. This is figure 12-6. And I'm interpreting that, one set of 2x12 or 2x10 is running to here, and the second one is running from here to here, and those two individual members are bearing on this larger joist or larger beam that is supported by steel, right? Because again, this piece of steel is here because we can't span this distance reasonably with 2x10. So we put this beam in the middle to help carry that load. But again, this is no different than what we would do in steel or concrete, right? We're taking a floor load, transferring it to a joist, to a beam, to a column, and ultimately to ground. But again, this notation here, 2x10 floor joist at 16 inches. Again, OC is on center. And this looks like it's right, showing how we're framing up some kind of opening here. Again, you as the contractor, you as the estimator, right? Let's say it's your job in the general contractor's office or the framing contractor's office to do the takeoff to bid the job, or your role on the team is the superintendent to actually go out, or the foreman to go out and supervise a set of tradesmen who are actually swinging the hammers. You want to make sure that you understand the practices that are used on that particular set of drawings. Just because the style of, or the way that a certain architect expresses or shows dimensions may differ from one set of drawings or one architect to another. So make sure that you understand the practices that that particular architect or designer are using. Again, they see here dimensions normally given to the outside edge of the studs. This is on figure 12-7. Interior walls dimensions normally given to the edges of the studs. And let's see if I have a picture of that. Oh, no, sorry. This is figure 12-8 on page 210, showing how we handle if we have some floor that's cantilevered or extended out over the foundation wall. We might do this in a case of, let's say if we have a porch, or probably more commonly a bay window. Right, I have a bay window actually two bay windows in my house, one in the dining room and one in the living room. And over the 100 years of my house being in existence, the bays have sagged a little bit. Yeah, this shows how you would cantilever or carry that load over the foundation wall. Okay, again, we talked about this before, platform framing and balloon framing. In balloon frame construction, that was more typical in the late 19th or early 20th century. You know, the house that I live in, the 100-year-old house, is balloon frame. So there's a long piece of old growth lumber that extends from my basement up to the attic. Two reasons why we got away from balloon framing. Probably first and foremost, finding long, straight pieces of lumber like that are more and more difficult. Number two, in balloon frame construction, we have this opening from floor to floor, and we found from a fire safety standpoint that opening, you know, makes it difficult for us to, makes it easy for fire to spread from one floor to another. But let me swap over, and just to remind you, let's So again, in that example there, you can see how balloon framing relies on long, straight pieces of lumber, right? In that case of a 2-story house, probably at least a 20-foot long 2x4 or 2x6, right? It's just hard to find lumber that good anymore. Oops. So let's look at platform framing.
Buildings can be comprised of many different types of materials. And as you can probably imagine, each one of those materials comes along with it its own unique assembly process. So being able to understand those two elements of a structural building system are critical in evaluating a project and determining what is the most appropriate material and method application for that given project. With this in mind, we're going to take a look at platform framing and some of the characteristics of this type of assembly process. So platform framing is the most popular method of light frame construction, primarily used in the residential construction industry, but not completely. So what we should really understand right from the beginning, platform framing operates off of a very simple building block concept. One block stacked on top of the other, supporting the blocks above it. So you can imagine how this type of system makes the method rather adaptable to different building types, particularly multi-level and single-story structures. So if we pull the skin away from these so-called building blocks, what do we find under that? Well, what we see is that each one of those building blocks has a set of support walls and a base to help support those walls. So very basic in nature, but let's dive into that even more and look at what that actually looks like and how it comes together. So let's start with the base or the platform. And if you didn't pick that up, yes, that's where the name platform framing comes from, because of this simple platform idea, building one on top of the other. So the platform is going to start with what's called a rim joist that you see here, and that creates the exterior envelope of the platform. Now within that is going to be the support system for the surface. And the support system is going to be comprised of two basic members, the girder beam, which you see here, and then intermediate joists that are going to be supported by the girder beam and also the perimeter foundation wall, which was already in when we started. Once that is all in place, that provides the support structure to put the surface on, which is going to be our decking. And the decking is going to be made up of 4-foot by 8-foot sheets of plywood, typically ranging anywhere from a 1/2 inch to 3/4 of an inch thickness. And the thickness of that plywood is going to vary depending on the spacing on your floor joists. And your spacing would typically be 16 inches or 24 inches on center. So once we have our platform in place, now the framing contractor has a good surface to work from to start building those support walls that we talked about. Those support walls are going to be comprised of 3 basic elements: a bottom plate and a top plate, which you see here, and those are going to create the horizontal extents of the wall system. Within the confines of the bottom plate and the top plate are going to go what's called the studs that you see here, and the studs are going to be fastened to the bottom plate and top plate, typically using nails. The studs will create the vertical support and also the vertical limits of the wall height. Now, these walls are going to be load bearing. So as you can imagine, when you start to put a load on the top of those walls, the studs are going to want to react to that load. So horizontal bridging is put in between the stud spaces to create a better load support for the wall system. So once the wall is all framed up, then it will be lifted into place and temporarily supported until the rest of the framework can be put in place. Now, when they put the wall in place, they are going to have to plumb it to make sure that it's standing perfectly vertical. They put their support, their temporary supports in place, and then begin building the rest of the walls. Now, what you're going to notice here is that the wall, they did not build the entire wall all in one piece. We have two different elements here. The reason for that is because, as you can imagine, the larger section of wall you build, the heavier it gets, consequently making it harder to manage when putting it in place. So they build it in segments, making it easier, more manageable in the installation. And the way those wall segments are tied together is with a second top plate, which you see here, that overlaps one wall from the other and gets tied together. So now you've got multiple wall segments within one run of wall that are built separately, put together, and then tied together with a top plate. And that process is going to be continuous all the way around the building perimeter, and then also on the interior of the building envelope as well. And that is the basic setup for giving you your box, your building block that we talked about earlier. You've got your base or your platform, and then your support walls on top of that platform. And if you have a multi-story structure, then the process is repeated for the second level until you get up to the roof level, where the roof is framed up, and that will be talked about in a later video. Now, the walls can either be sheathed after they're all permanently in place or while you're framing them on the platform. There's advantages and disadvantages to both, and I'll leave that for you to think about on your own.
Okay, well, that was, we had played that a number of weeks ago, but it was a good reminder to see how stuff gets put together. Does that make sense what platform framing is?
Yes, I actually had a question about the note that you made about exterior dimensions are to the outside edge of the stud, and then the interior dimensions are to the edge of the studs without the drywall or the finished material. I was reading that from the book. Is there a way to put that on a picture? Just kind of point to that on a picture?
Yes. I see it in figure 12-7 on page 209. And if I get a chance during break, I'll stick that up on the slides here, and we can make sure. I think really my takeaway from this is make sure that you understand the dimensioning practice that's being used on the drawings that you're looking for. Right? There's no right way or wrong way. I mean, there's probably a more common way, but just make sure that we understand the practices that the particular designer is using.
Okay.
And I think when we get to probably on Thursday, we'll go back to Sullivan and Marseille. We'll figure out what practices they're using for dimensioning there.
Okay.
You're welcome. Okay, we talked about platform and balloon framing. Right, this is figure 12-10 on page 210 in the book. Right, some details for balloon framing. Again, we got away from balloon framing from a fire safety standpoint, although you see that they've put some fire stops in here to try to get away from that fire safety consideration. But again, I'm assuming two things happened here. Number one, the availability of long sticks of lumber. And number two, I'm guessing we figured out that platform framing can be done cheaper and faster, right? If it was cheaper and faster to do with balloon framing, we'd probably be doing it that way. But somewhere along the line, we came up with a better, more economical way of framing up houses, right? We're trying to deliver housing at a reasonable cost. Yes, Ayana.
You know, I just had a quick question because, like, I guess you're saying the balloon framing predates the platform framing, and I hear so much about like how the Amish are great builders. Do you know anything about like the Amish building practices and if they probably not that they originated or like started balloon framing, but like is that what they probably use today?
I don't know. That is a good question. I think that the Amish are certainly. I can picture in my mind the Amish doing a barn raising, right? Kind of a collective or a community event, and I think in that case they're typically using heavy timber or post and beam construction, which we'll get to in a little bit. I actually don't know how the Amish build their houses. I will have to see if I can find something out. But you can envision when you looked at the picture of that little video of balloon framing, right? The two-story section was built on the ground and tilted up. So I could picture that being a cooperative effort amongst a community of Amish folks trying to build somebody's house. But I will see if I can find out some more about that. Right, again, here's our balloon frame construction. It's a little harder to see in this case what the characteristics are, except for the fact that you see these individual members that are extending all the way from foundation wall to the roof. Right, as we saw before, platform framing, we're stacking, as a gentleman in the video said, we're stacking components on top of each other. First floor is built on top of the foundation. First floor walls are built on that platform. The second floor platform is built on top of the first floor walls, et cetera, et cetera. And this is figure 12-9 in the book. Again, here's our foundation wall with the anchor bolt, the sill plate, the header, the joists, and then the subfloor. He talked about plywood, 4x8 sheets of plywood, and then a sole plate, and here's our vertical members or studs built on top of that, double top plate, and then the joists for the second floor built using the support from the first floor, and we do it all over again. Sorry, it's a little, the images are a little fuzzy here. But again, this reinforces the concept of a box or a a box on the first floor and another box that comprises the second floor. Sole plate, floor joists, plywood or subfloor, joists, double top plate, joists, subfloor, supporting the joists on the second floor. The third general framing system would be post and beam. So in this case, we're using heavy timber or potentially engineered lumber for the posts and columns. We're using, instead of sheet goods like plywood, we're using planks for the flooring and the roofing, because those planks have to span longer than what the sheet good, the 3/4 or 1/2-inch plywood would be able to span. Structural members placed at wider intervals. To make the point here that this allows for some more interesting architectural or decorative effects. such as this. Right, looks like somebody's very nice, attractive vacation home. I'm going to guess that you can't build something like this at a cost that you would use for, typical suburban tract homes, which is why we use platform framing. But again, if you're an architect and you're so lucky to secure a client who has a nice site up on a lake in Wisconsin or in the woods of Wisconsin and says, design me a great looking house, you might go to something like this. But again, this looks in some respects very similar to steel or concrete construction, right? Heavier columns, structural members, beams, wider spacing. Number of different ways that yeah, there's going to be less, Christoph, certainly less members involved in post and beam construction than there are in more conventional framing, right? We see this whole, certainly this wide expanse of window. Right? Somewhere in here, there's going to be a structural member. So yeah, we have a lot fewer members, but each member is larger and deeper. So there's obviously a trade-off. Again, my guess, the trade-off is that lots of different contractors and lots of different tradesmen can build using that platform framing, whereas there are likely a lot fewer people who have the skills necessary to build successfully with post and beam. So you're going to pay a premium for that, would be my hunch. Again, if this was the more economical framing system, we would see this, all throughout the suburbs, but that's not what we see, right? We see platform frame construction. That makes sense? Got it. Okay. Again, a couple different ways that we can join those posts and beams, right? We can go back to kind of old-fashioned mortise and tenon joint, or we can make cuts and support them with steel plates and through bolts. Again, a number of different ways that we can support this, and this is fundamentally no different than right when we looked at reinforced concrete. We saw a concrete column and a concrete beam, and we saw lots of rebar that was being used to transfer the load from one member to another. Certainly in steel, we would see either a bolted or a welded connection, again, transferring load from one member to another. In this case, we're a couple different techniques for joining beam or girder to column and transferring that load to the column and ultimately to bear on soil. Okay, it's top of the hour here. Why don't we take a 10-minute break or so, and then we will continue.